In the third problem in this set, we have the rate at which people enter an amusement park on a given day being modeled by the function e for enter, defined by e of t is equal to 15,600 over the quantity t squared minus 24t plus 160. Then the rate at which people leave the amusement park on the same day is modeled by the function L, defined by L of t is 9890 over the quantity t squared minus 38t plus 370. Now both E of t and L of t are measured in people per hour, and time t is measured in hours after midnight. So these functions are valid for the times between 9 and 23 inclusive, the hours during which the park is open. At time t equals 9, there are no people in the park. Part A asks, how many people have entered the park by 5 p.m., that is at t equals 17? Round your answer to the nearest whole number. So if we're looking for the number of people who have entered the park by time t equals 17, then we want to take the integral of that rate. Remember that E of t is a rate, keyword, and L of t is also a rate. And the rate is in people per hour. When we multiply that by a number of hours, we're going to get people. So the integral, or the area under that E of t curve, is going to tell us the change in the underlying function. E of t is a derivative. The integral of that will tell us the change in the people function, or the number of people, the function that models the number of people in the park who have entered the park. So for part A, we simply are looking for the integral from 9 to 17 of E of t dt. E of t is a derivative, and the integral of that derivative will give us the net change in the number of people over that hourly interval. So we're going to bring in the calculator, put that function E of t in y1, and then take the integral from 9 to 17. So I open the graphing calculator, I go into y equals, and I want to put in the function 15,600 divided by, and I do need parentheses here around the denominator, x squared minus 24x plus 160, close parentheses, and 15,600 divided by x squared minus 24x plus 160. Now, I am going to take the integral of that from 9 to 17, but this time I'm not going to go to the graph. Instead, I'm going to use the math up arrow fn int. That helps me to find the integral. My function is vars, yvars, function y1. I want the integral of that y1 function. Now I have to tell it the variable of integration, which is x. It will always be x. And from 9 to 17, close paren, and it gives me 6,004 rounded to the nearest person, so the answer will be 6,004. So that's the answer to part A. 6,004 people have, according to the model, have entered the park by 5 o'clock. T equals 17. Okay, I'm going to close the graphing calculator and go into part B. Well, we're going to run out of time on this video, so I'll start part B in the next video and stop this one here.